Good afternoon. We are going to review three different types of solving by factoring, solving by square roots, and solving using the quadratic formula. I'm going to go over a couple different types of factoring. I do not have the time to go over all types of factoring, but if you have your factoring notes from last year with the chart that has all of the different factoring formulas on it, that might be something you want to pull up and remind yourself of. So solving by factoring, square roots, and the quadratic formula. And these notes are designed to go with worksheet algebra point 6, which is the first of our solving worksheets. All right, Roman numeral 1, factoring. Remember, when you solve by factoring, the key to it is to set the equation equal to 0. And when we set it equal to 0, we use something called the zero product property, which says if you have two expressions multiplied together and they equal 0, the only way that would happen would be if the first one was 0, so A is 0, or the second one could be 0, B could be 0, or they both could be 0. And we actually don't know which one is the case. So of the three, we pick the both, find two answers, or 3 or 4 answers, and then we test the answers to see which ones will work and which ones won't. So that's zero product property. Okay, the first example I'm going to show you is the method of factoring by dividing out. This is sometimes called reverse distribution, but we tend to forget it because it's so easy. It's not one that we cover a whole lot. So here's our example. 8x squared minus 4x equals 0. So when you factor an expression, the first step is always to divide out whatever you can to the front. These are monomials, so I can divide a 4 to the front, and I can divide an x to the front. This will leave us with a 2x minus a 1. If you're not sure if you've divided out correctly, just remultiply by distributing and make sure you have it. Okay, so now that we have our two expressions, 2x minus 1 is not factorable any further than it is already, so we're done. We're ready to use zero product property. The 4x is like our A, and the 2x minus 1 is like our B, equal to 0. So we're going to take the 4x and say, okay, what value of x would make that piece 0? And we're going to do the same with the other factor. What value of x would make 2x minus 1 equal to 0? Remember, we're trying to figure out how they multiplied to get a 0. So on the first one, we multiply both sides by a fourth, and x would have to be 0 for a 4x to be a 0. Now the next one, add 1 to both sides. You get 2x equals 1. Multiply both sides by a half, and you get x equals 1/2. If x is 1/2, then this second factor would give you a 0. So that is factoring by dividing out. Okay, number 2, ABC factoring. This is a type of factoring that's done with trinomials. And it's one of the most common, but sometimes the most challenging. Okay, here's our example. 3x squared plus 3x minus 36 equals 0. We are going to solve for x. So the first thing you always do is divide out what you can. Well, I can take a 3 out of all of these. That leaves me with x squared plus x minus 12 equals 0. So that 3 stays a scalar on our final answer. So we're going to ignore it for a little while here. For ABC factoring, A is the coefficient on the first term, B is the coefficient on the second, C is the third term. So if you remember how to do factoring with ABC, you list factors of A, which are 1 and 1, -1 and -1. We don't use the double negatives on A. List factors of C. There's a lot of factors for this one. Negative 1 times 12, 1 times a negative 12, 2 times a negative 6, negative 2 times a positive 6, 3 times negative 4, negative 3 times positive 4. So what we're looking for is a combination where we can multiply one factor from each pair and then add it together, and we want it to be a 1. Well, this one's pretty easy because the a is 1, so these two are going to simply multiply by 1, so it's going to be this one. But let's say that you didn't know that, so you picked something else. So let's pick 2 and negative 6. I'm going to show you what it looks like when it's the wrong pair. So each set can go together two different ways. First terms, 1 times 2. Second terms, 1 times negative 6. That would be 2 minus 6, which is negative 4. And then inside terms and outside terms. So inside terms, 1 and 2. Outside terms, 1 and negative 6, which of course gave us the negative 4. Now, the correct one happens to be this, because if you take first terms and second terms, first term 1 times first term negative 3, plus second term 1 times second term 4, you get negative 3 plus 4, which is 1. And remember, you are looking for your b value, which in this case is a 1. So we have a winner right there. All right, now we're going to put it together. The 3 goes in the front. You're going to have 2 sets of parentheses, and I'm going to have to continue this on the next page. This is equal to 0. So remember that your factors of a always go in the first position. So I have a 1x and a 1x. Factors of c go in the second position, and I have a minus 3 and a plus 4. And you want to do a really quick rainbow check to see if you have your c's in the right spot. So I have a negative 3 on the inside, a 4 on the outside. Yep, I got this right. All right, so that is completely factored. Now, at this point, you would want to set each of these equal to 0 and try to solve it. Let me switch pages here. So we have 3 times x minus 3 times x plus 4 equals 0. Now we're going to solve. So using zero product property, I have 3 things multiplied together. Set each of them equal to 0 and see what x will make that factor equal to 0. Well, in the first one, it doesn't have an x, and 3 is definitely not equal to 0. So that first factor is a no solution. It doesn't give us a possible x. The second one, obviously, if x is 3, that expression would be 0. So there's one of our answers. Second one, if x is negative 4, that would be another one of our answers. So x could be 3 or 4. Okay, that is ABC factoring. All right, third type of factoring I'm going to review is the difference of two squares. Difference of two squares. And there's a pattern for this. If you have a perfect square minus a perfect square, then it factors into a plus b times a minus b. So for example, let's say you've got 2x squared minus 18 equals 0. All right, first thing you do when you solve by factoring, you always divide out what you can. I can take a 2 out. That leaves me with x squared minus 9. Now obviously 2, when set equal to 0, is not going to give me a solution, but this one might. And your test is, can you write it as something squared minus something squared? If you can, you do have your a and your b. So I can write this as an x squared and 9 as a 3 squared. So yeah, it works. So my a value is x, my b value is 3. I'm going to use the pattern to factor. A plus b, so x plus 3, a minus bx minus 3. Now, if we're just factoring, you'd park the 2 out, you'd be done factoring. We are actually solving though, so it's equal to 0. Again, we're going to use zero product property. We have 3 possible factors to give us answers. So set each of them equal to 0. 2 equals 0, x plus 3 equals 0, x minus 3 equals 0, and solve for x. 2 is not equal to 0, so that factor is not a solution for x. The middle one, x is negative 3, that will work. The right one, x is positive 3, that will work. So you have 2 possible answers, 3 and negative 3. Okay, so the 4th type of factoring I'm going to review, and the last one that I'm going to review today, is the sum and difference of 2 cubes. Sum and difference of 2 cubes. All right, so you do have a couple of formulas for this. If you have a cubed plus a b cubed, it factors into a plus b times a squared minus ab plus b squared. If you have an a cubed minus ab cubed, then it factors into a minus b, and then a squared plus ab plus b squared. So our example is going to be 8x cubed minus 27. We're going to factor this. First things first, divide out what you can. I can't divide anything out. So second thing, see if you can write this as something cubed minus something cubed. Obviously, it has to be a minus, the difference, because this has a negative in it. So 8 is 222, so put a 2. X cubed is xxx. 27 is 333, so 3 cubed. So my a is 2x, my b is a 3. Now I'm going to put it into the formula. A minus b, so 2x minus 3 times a squared, so 2x squared, plus a times b, so 2x times 3, plus b squared, so 3 squared. And all we need to do is simplify a little bit. So 2x minus 3 is good. 2 squared is 4. X squared is x squared. 2 times 3 is 6. Tag the x. 3 times 3 is 9. Now, if you were actually going to solve this with factoring, this one would be not factorable to solve, and this one would give you x equals 3 halves. Naturally, most of the time in doing this work, we would use quadratic formula for that last part. But if they say solve by factoring, then that's the only one you can get definitively just using factoring. All right, Roman numeral 2, we're going to review the quadratic formula. Quadratic formula actually works on any quadratic, but it tends to be a little time consuming, so we tend to factor to solve first, and then if that fails, we do the quadratic formula. So for the quadratic formula to work, you need an expression in the form ax squared plus bx plus c equals 0. Using that form, x equals negative 1 times b plus and minus the square root of b squared minus 4ac, and then everything over a 2 times an a. All right, so here's our example. 2x squared minus x plus 2 equals 0. Okay, so our a is 2, our b is a negative 1 coefficient, our c is 2. So we feed them into the formula. Negative 1 times b, which is negative 1, plus and minus the square root of b squared, so negative 1 squared, minus 4 times a, which is 2, times c, which is also 2, all over 2 times a, 2 times 2. Now it's a game of simplifying. You can simplify the outside pieces right away. -1 times -1 is +1. 2 times 2 is a 4. Now inside this radical, you need to do the exponent first. So I'm going to pull this out here to the side. -1 times -1 is +1. And then you need to multiply -4 times 2 times 2. If you think of this as a -4, it will keep you from making negative issues in the future, negative errors. -4 times 2 is -8, times -2 is -16. So we get a -15. So this is 1 plus and minus the square root of -15. Now, if you get a negative under a radical, remember that the square root of -1 is always an I. So you separate out the radical into square root 15 times square root of -1. That's one of the properties you learned, that you can always split a radicand into two different radicands, factors of the original. This gets replaced by an I. Let me put the 4 back. And you get 1 plus and minus radical 15I all over 4. Now, when it comes to complex or imaginary answers, you remember that the standard form is a plus bi. So you need to separate the I fraction from the real fraction. So x equals 1/4 plus and minus radical 15 over 4, I on the side. Quick check at this point. Is there anything that can be reduced? Because sometimes when you split it, what's left will actually reduce. There isn't, so this would be our final two answers. Using quadratic, you will always get two answers unless the second part is 0. Otherwise, the plus and the minus give you two answers. All right, last review. Roman numeral 3 is completing the square or taking square roots. I think for this worksheet, it's just taking square roots. So we're going to cover that, and then I'll cover completing the square later. So we're going to solve by taking square roots. All right, example 1. You've got an x squared equals a 16. When you have a perfect square, x on one side with no scalar equals a number on the other side, there is a shortcut for solving. You may take a square root of both sides, everything on the left, everything on the right. Now, here's where it gets tricky though, as all shortcuts do. Remember that x squared is originally positive. We don't know what x is, so it could have been a positive number, because a positive times a positive would be a positive x squared, but x could also have been a negative number. And when you multiply a negative times a negative, you also get a positive. So there's a really big question mark which one it is. So just like zero product property, we do both. And then we test to see what works and what doesn't. So here we have two x's, one comes out. It could be positive, it could be negative, we don't know which. Now 16 is 4 times 4, 2 4s, one comes out. So this is where we split. You can have a positive x equals 4 and a negative x equals 4. Obviously for x equals 4, that's your answer. Here, multiply or divide by -1, you get x equals -4. So you still get your two answers. It's just it's a little shorter than the quadratic or even completing the square. And again, the really difficult part for people to remember is this plus minus. That has to be there. All right, let's do one last example of taking square roots. We'll do something a little bit more complicated. X minus 1 squared equals 16. Now, this still works with the shortcut because you have a perfect square equals a 16, and all the x's are in that perfect square. So you're good to go. We take a square root of both sides. 2x minus 1 comes out. It could be positive, it could be negative, we don't know which. Square root 16 is again 4. So now we're going to split into positive and negative sides. Positive x minus 1 equals 4. Negative quantity x minus 1 equals 4. And solve separately. So on the left, when you distribute a positive, of course, nothing changes. We're just going to add 1 to the right. X equals 5. Okay, on the right, you have a choice. You can move the negative or you can distribute. I'm going to distribute just to show you maybe a different way to look at it. Negative times x is negative x. Negative times a negative is a positive 1. We're going to subtract 1 from both sides. You get negative x equals 3. So x equals negative 3. Now, did you notice? X is not plus and minus 5. It's two completely different numbers. So that's one of the misunderstandings that come out of Algebra 1, which is that when you solve by taking square roots of both sides, that you're going to end up with plus minus the same number. Well, that's not it. They can be plus minus the same number, but they can also be completely different numbers, which is actually more the case. I hope this review was helpful for you. We will be practicing solving for a few days to remember how to do these different things. I will do the notes on completing the square later when we get to the completing the square worksheet. That's all.